We will start works connected with building foundations with removing a fertile layer of soil, that is the so-called humus topsoil. To this end, we will use heavy equipment. We have a wide choice here, however I will use a backhoe loader, which is a very multi-purpose piece of equipment and will help us to deal with many unpredicted situations. As can be seen, we commenced works in the very early spring, so remainings of snow can still be noticed, whereas the soil remained frozen as deep as even 60 centimeters at places. It presents a really difficult challenge for a backhoe loader. Please notice how big the frozen blocks excavated by the operator are. Such a state of affairs is of course reflected in quite a considerable prolongation of the time the equipment is in use. In normal conditions, the project of removing humus takes around 2-3 hours. In this case, however, it lasted more than 9 hours, which resulted also in threefold increase in cost compared to a planned budget. Therefore, it is good to consider this when planning the building in the early spring. On the other hand, however, in some conditions, such a state of affairs may be useful despite the problems that we have with removing humus, namely in the event that the ground is loamy and wet. This is exactly the case in the example discussed. The water table here is located nearly over a dozen centimeters below the level of foundation of the building, while the soil that is presented here is loam. Loam as a rock is considered to be a bearing ground, good to erect a building. Nevertheless, we have to fulfill certain conditions. The first and the most elementary one is that we can't disturb its natural structure, therefore we will have to dig for the strip foundations by hand, whereas the other one is that we can't let such a pit to be soaked. These conditions are very difficult to meet, but we have a chance to fulfill them as well as to backfill the strip foundations already prior to the spring blustery weather, due to the fact that in the case presented there is still a slight frost. If we fail to make it in time, we may be faced with the situation that we can see here on the example of the second pit which we make on the same plot of land for a utility building. Here the ground is lower and the water table appears at the height of the foundation. The pit is made approximately 1 month later, and please notice how the situation looks like. Loam is softened and damp, hence there is absolutely no chance to erect anything on it. It also lost its bearing capacity, plus as an aggregate is not suitable to be compacted. Therefore we need to replace it. I decided to dip the pit around 1 meter below the level of foundation of the building. Please notice that what result is quite a sizable lake. Of course, all water from such a pit must be removed. The easiest way to do it will be to drain it with a pump, exactly the kind that we can observe in the film. In such difficult ground conditions as we have here, it is good to consider founding a building on a slab-on-grid that is made above the frost depth. The slab-on-grid itself shifts the weight of the building to a considerable degree. Obviously, this entails a partial change of the project. In order to be prepared for such eventualities, I recommended carrying out a geological survey of the ground, thanks to which we will know what to expect already prior to commencing works. I also recommend choosing a construction manager who is open to different construction solutions. In the presented case, after draining the pit, I replaced the ground with an aggregate of 0 to 3 mm fraction, which is suitable for compacting. This, of course, should be done layer by layer, depending on the mass of the compactor. The one that I use weighed 90 kilos, so each layer will be up to 30 centimeters thick. It was only after a true compacting of the ground being replaced that we commenced making a pit for a strip foundation. I will present the manner of compacting later on during performance of a ground-supported floor. This pit was presented by me as a curiosity, so let us now go back to the building process itself. We are also going back in the time a little bit, and thus the ground is still slightly frozen. The temperature outside is somewhat above zero. We can now observe surveyors preparing for works. They will delimit access of walls as well as centers of spot footings. Please pay attention to the way it is done. Initially, a surveyor uses a wooden ground stake with a cross marked on it. The cross represents the point of intersection of axes of the bearing walls of the building, while in case of the spot footings, it constitutes the center of such a spot footing. By means of measuring devices, a surveyor is able to determine these points with a nearly millimeter accuracy. Next, simple devices called profile boards have to be made, which will reflect the points marked before. We can see them in the film. As can be noticed, they are made with two wooden ground stakes, as well as a board attached to them horizontally. Two profile boards are oppositely made for each bearing wall. The nails being driven in now reflect the straight line which goes through the points marked with crosses on the earlier prepared ground stakes. Now, when we join the opposite nails with a rope, we will obtain the axis of the wall. As for the ropes of vertical profile boards, they intersect at the point of intersection of bearing walls axes. In order to determine the centers of spot footings, the surveyors have to make as many as 4 profile boards for each footing. Since in the presented project there are as many as 4 footings, we have here quite a lot of profile boards. The boards are nailed at the distance of approximately 1.5 meters from the walls of the building, so they don't disrupt works. Now we can observe the first implementation of the devices. We will use them to derive the line of the pit for a strip foundation, as well as to determine the depth of the side pit. Please notice how easily it can be done with the use of profile boards. It is enough to measure 40 centimeters on each side from the nail representing the axis of the wall. Driving nails in these places, do exactly the same with the opposite profile board, and then join the nails together by means of a rope. In this way, we obtain the line of the pit, which is 80 centimeters wide. We will dig quite a wide pit for the profile boards, as the profile boards themselves will be made in formworks. Therefore, we will need some place to perform carpentry works. As for determining the depth of the pit, all boards of the profile boards are attached at exactly the same level. Thus, all the ropes that we see here are located at exactly the same level as well. This level is known to us, described by the surveyor, and expressed in meters above the sea level. On the other hand, the level of funding the building is described in a building permit designed by a town planner according to the conditions of land development for a given plot of land, and is also expressed in meters above the sea level. Once we have those two levels, it is enough to deduct one from the other in order to find out the depth at which the bottom of the pit, measuring from the rope, will be located. Please pay attention to the fact that we are digging the pit at the time when the soil is still a little bit frozen. it causes a slight delay in works for, as can be seen, we have to use a pickaxe and get a little wary working with a spade. However, the advantages are considerable since, firstly, the ground is dry, and secondly, the edges of the pit don't sink, which also influence to quality of works. As I mentioned earlier, we have quite a lot of profile boards. We will make as many as 4 isolated footings in the foundation, on which load-bearing columns will be placed that will shift the weight of the ceiling and the arch-shaped lintels. So I will be able to discuss here a lot of interesting constructions made of reinforcement concrete. Indeed, the entire project is quite useful for didactic purposes. However, let's go back to groundworks. We are moving on to next stage, that is placing a concrete bed for the actual strip foundation. In a specification of every building permit design, we may notice that strip foundations are to be placed on a concrete bed that is around 7 cm thick. Unfortunately, most contractors don't abide by it. So in fact, what they do is carrying out the project contrary to construction treat practice and specification from the very beginning. That is simply realizing it discordantly with an architect's orders. Moreover, the majority of contractors simply cast strip foundation later on straight into the ditch's deck, causing the structural concrete to mix with the soil and be subjected to a very quick loss of water, which in turn causes its weakening. In addition, the contractor has no control over what is happening with the reinforcement, which in such case is probably exposed in many places to direct contact with the soil and corrosions as well. I will discuss it in the next chapter. Here, I would like to direct your attention to the fact that in order to level the concrete beds for a strip foundation, we used wooden ground stakes that we align using a spirit level and checking their distance from the ropes. These ground stakes will be our reference now, since ropes of the butterboards were removed so that they would not interfere with casting the concrete. As precise leveling of this layer as possible will indeed be extremely useful for us during placing formwork of strip foundations, as we won't have to level them. It will be enough to perform a slight inspection of the level. To make this part we use concrete class B7.5, almost dry consistency. I'd like to invite you to watch the next chapter of this part, which contains information on how to properly make strip foundations.